I want to go over the questions from the positive physics, specifically the trigonometry part, the 4 questions I assigned to you yesterday. If you're having trouble, please watch this video. Now, of course, the numbers in my problems are different than yours, but the steps will be exactly the same. Okay, the first one. A student is pulling a box by applying a 220 Newton tension to the rope. Here is that force. This is the angle that was given. Your angle is going to be different. So the tension, this is the 220 is the diagonal, because that is the force that's in the rope. So that is 220 newtons. Now what we can do with this is, because we have the 18 degrees, we can kind of create a right triangle here using that, and we can figure out the horizontal component and the vertical component. So let's find the force in the x direction and the force in the y direction. So just like if we were using velocities, we use the same exact formulas to do this. Okay, so to find the force in the x, I'm going to use cosine. So cosine of 18 degrees is equal to the force in the x direction over 220 newtons, adjacent over hypotenuse. Rearrange that. We're going to have 220 newtons times the cosine of 18 is equal to the force in the x direction. We can then calculate that, and we can get our answer. And we can just type that right into the calculator once it's in this form, and we should get the force in the x direction to be 209 newtons. Of course, different for yours. Now, for the vertical tension, we would do the same thing, but we're now looking at the f of y. It is opposite the 18-degree angle, so I'm going to use the sine this time. So sine of 18 is going to be equal to the f of y over 220 newtons, opposite over hypotenuse. Rearrange it. 220 newtons times sine of 18 equals f of y. And then, of course, do that math, type it in, and you will get your answer. In that case, my component of vertical tension is 68 newtons for this one. Let's start number 2 now. Here is the second one. A pendulum is in the position shown. The vertical component is 27 newtons. Determine all unknowns. So we're looking at our triangle, and this time the number that was given to us is the vertical component, which is this, 27 newtons. So that is the vertical tension only in this direction. We want to now figure out the rest. So let's see here. Let's first figure out the tension force here. So that would be, let's see, I'm going to use cosine to find this one. This is going to be tension. This will be tension in the x direction. Let's do our math here. So to find this, I'm going to use cosine. Cosine of 23, the angle is 23, is equal to adjacent over hypotenuse. So that's going to be 27 newtons over the tension force. If we arrange this one, we actually have to multiply the t over to this side and then divide out the cosine of 23. So this will become t is equal to 27 newtons divided by cosine of 23. That's how we would get our answer for the tension in this case. That answer would end up being, let me calculate it real fast, 29.3 newtons. Oops, sorry. 29.3 newtons. Now to get the horizontal component, we're looking for the tension in the x direction. I don't know, we can use any one of these. Since I have this one and I have this one, I have the adjacent and the opposite, I'm going to use tangent. Tangent of 23 degrees is going to equal opposite over adjacent. Opposite is t of x, and adjacent is the 27 newtons. And I can rearrange this, multiply the 27 over to the other side. So 27 times tangent 23 is going to equal my t of x, which, if I do my calculations, the horizontal component of the tension ends up being 11.5 newtons. And that's how you will end up solving number 2. Alright, we are going to now move on to number 3. Okay, here's number 3. A helicopter is maintaining a constant altitude because the vertical component of the thrust is 21,000 newtons. This one, you know, I would guess that you might have had a little bit of difficulty because of the way it's set up. So helicopters do tilt themselves so that they can move forward, and also the upward thrust is going to keep them from falling to the ground. So that angle, that's going to propel it forward while also keeping it from falling. So the vertical component of this, and I'm going to make a triangle right here, and your triangle is going to be right here. The vertical component of that is the 21,000 newtons. So the thrust, which is a force, so this is the thrust, and this is the thrust in the x direction, or horizontal. And we were given the 2100 for the vertical. Now you're wondering, well, what about the angle? This tilt, since I don't know, are they called skis of the helicopter? Anyhow, parallel with the blades, this triangle and this angle, it's also similar up here. So this 21 degrees can go right there into that triangle. And now we can do the math. Now that you have it set up, I think the rest is actually pretty easy for all of you. So the 2100 newtons, that's the vertical. I keep saying 2100, 21,000 newtons is what I'm actually dealing with here. We can go ahead and set up the other one. So let's do the thrust, which is this one. So I'm going to use cosine because I have adjacent and hypotenuse. So cosine of 21 degrees is equal to adjacent over hypotenuse. So that's 21,000 newtons divided by the thrust. I'm going to rearrange that just like I did in the last problem. And I will have thrust is equal to 21,000 newtons divided by cosine of 21 degrees. And I can type that in. I will get my answer. My answer is 22,494. And that is newtons. 22,494. Just like I said before, your answers will be different than mine. That's okay. Alright, now to get the thrust in the x direction, I'm going to use tangent because I have the adjacent, I have the opposite. So tangent of 21 degrees is equal to opposite over adjacent. T of x over 21,000 newtons. Rearrange that, and we will have tension in the x direction is equal to 21,000 newtons times tangent of 21 degrees. Type that in, we will get our answer. Our answer is 8,061 newtons. Okay, so that's number 3. The steps were very similar to number 2. But I think the difficulty there was getting it set up because the picture didn't really, it wasn't as helpful. Last but not least is number 4. Here it is. And it's slightly different, but really we're still doing the same thing. But we are going to work our way backwards in this case and figure out what the original angle was for this one. So, a helicopter is generating a 6,000 Newton horizontal thrust. So let me make our little triangle here. 6,000 newtons is horizontal, so that's going right here. And I'm going to write that in here. 6,000 newtons horizontal thrust. And a 29,000 Newton vertical thrust. Wow, this one's nice because it's giving us a lot of information. So 29 29,000 newtons vertical. So we want to find this. Now this is our thrust, and we have a right triangle here. So in order to do that, oh, by the way, this theta goes up there. In order to do that, we can use a Pythagorean theorem on this because we have 2 out of 3 sides of a right triangle. So 29,000 newtons squared plus 6,000 newtons squared is equal to thrust squared. Let's see. Square those, add them together, square root it. Anyhow, we would end up getting thrust equal to, and you know, that part I think you could do on your own. The thrust here is going to be equal to 29,614. 29,614 newtons. Of course, your numbers being different. So the Pythagorean theorem part, I'm pretty sure you guys have that because you're good at that. But this is the other part, is going backwards to find this angle. So here's my angle. I have the adjacent side and the opposite side. So I'm going to use a tangent. Tangent of the angle theta, which is our unknown, is equal to the opposite side over the adjacent side. So 6,000 newtons over 29,000 newtons. In order to solve that, we have to release the theta from the tangent. So we have to do that reverse tangent. So theta is equal to inverse tangent of 6,000 over 29,000. Type that in, do your math, plug it right into the calculator, and you should get your answer. In that case, my angle, the helicopter was tilted at an angle of 11.7 degrees. So those are the steps that you would use to complete all your problems. Of course, yours will have different numbers. But if you were struggling yesterday, you should now be able to go back in and do the rest of these. If you have any questions, let me know.